So we're going to do another example here, and this example we're going to do an actual chemistry example. So in this question, we're asked to determine the number of molecules found in 5 moles of water. So let's do some highlighting. So one of our givens here is the 5 moles of water, okay? The unknown in this question, so what we're looking for, is the number of molecules. So let's write out first what we're given. So in this question, the number of moles, which is shown as little n, is equal to 5.00 mole. We're asked to determine the number of molecules, and we're not given any other information, but you can use Avogadro's number to convert between these. So that's something that you'll need to know. It is on the back of the periodic table, in case you need to reference it. But that is denoted by capital N with a subscript of A, and that's equal to 6.02 times 10 to the 23, and it's particles per mole. And the particle in this example will be the number of molecules. So 6.02 times 10 to the 23 molecules, and it's per mole. So per mole, I could have written this like I did above over here with the fraction. I could have written it like uh, per mole, oops, per mole, or I could have written it as per 1 mole. Whether or not I choose to write the 1 in this over here is like it's the same thing. It doesn't matter. So those are the givens for this question. The number of moles is the given, and then the Avogadro's number is the conversion factor that we need to use. And we're looking for the number of molecules, so that's going to be the unknown. So the unknown is capital N, which sometimes I'll use the placeholders. Sometimes I'll just write, instead I'll write number of molecules equals question mark. You could also just write that, sometimes I write it like that, sometimes I write it as capital N, which is the placeholder for number of like particles. N equals question mark molecules. Just two different ways that I write it, but make sure that for each of your givens, you're writing the units, and the same for the unknown, because then when you set up your equation, you know exactly what needs to go where. So let's start setting up this equation. So this is when so at this point, I usually just drop the placeholder and I only use these units. So number of molecules, that's our unknown, equals, I'm going to start off with the number that doesn't have a fraction. So out of these two values, this one up here, the 5.0 mole, that's not a conversion factor. And so there's no fraction associated with it. So I'm going to use this number to start off the equation. So 5.00 mole. And then I need to have a fraction in order to convert moles into molecules. So I'm looking at this here, and it need to have moles on the denominator. So if I just scroll up for a second here, up here we had students, and students had to cancel with students. So that stayed the same over here. But then once I canceled the students, I needed to cancel out slices because I wanted to get to boxes. So I had to flip this fraction. So that slices was on the denominator and boxes was in the numerator. So that's for this one, I don't need to flip this fraction because I already have moles in the numerator here, and I need moles in the denominator. So I don't have to do anything to the fraction. So it's just 6.02 times 10 to the 23 molecules per mole. And when I have moles like this in the denominator and no number next to it, it means 1. So there's 6.02 times 10 to the 23 molecules per 1 mole. And because I have moles in the numerator right here, and I have moles in the denominator over here, these guys are going to cancel. So when I put this into the calculator, I have a calculator here now. Let's put it in the scientific calculator so that I can do my scientific notation. I have 5 times 6.02. I'm using this EE right here. For some reason, this 10 to the x, I'm not really sure what this button on this calculator does, but this is the scientific notation button. So that's what I'm selecting for this. So 6.02 times 10 to the power of 23, enter, is 3.01 times 10 to the 24. So let's get rid of that. So equals 3.01 times 10 to the 24. My unit that's left over is molecules. Oh my gosh, can't spell today. Molecules. And that was exactly what I was looking for. So we're at the end now. This has to be rounded to the correct number of significant digits. And I have 3 significant digits over here in my my given, as well as the conversion factor, but conversion factors we don't really worry about for the significant digits. So that's how many significant digits it is. So 3. So I don't need to round it or anything, but I should write a statement. Therefore, 3.01 times 10 to the power of 24 water molecules.